The next topic is multiple regression analysis. So it's an extension to the simple linear model. So instead of just one x, we have a bunch of x's. So we start with beta sub 0 plus beta sub 1 x sub 1 and so on plus an error. So y is the dependent variable or response variable, and x sub I is the ith independent variable or predictor variable or explanatory variable. Okay, beta sub 0 is your intercept, and usually intercept is not interpretable, but you have to have it. Okay, and then beta sub I is the coefficient of the ith slope coefficient of the ith independent variable. K is the number of independent variables. E is the random error. So like in simple regression, we have the least squares estimate. So we want to estimate, we want estimates for all these beta coefficients such that the sum of squared error, y minus y hat, squared and summed, that sum of squared error has the least possible value. Okay, and that's that. Okay. Now, unlike simple regression where we have formula for b sub 1 and then a formula for b sub 0, okay, we don't have formulas for these coefficients when we have multiple slope coefficients. So we have to use the regression command in Excel to develop these values. So let's look at an example, which is Jenny Wilson Realty. And here we have two, so we have selling price of the house. Okay, that's what we want to predict. Okay, if a house comes into market, we want to assess what would be the selling price for that house. And we're going to use three different variables. Okay, square footage, age of the house, and then what condition the house is in. And you notice that the condition is given as a non-numerical variable. So this has to be dealt with in a particular fashion. So what we're going to do first is not worry about the condition. We'll only use these two variables. We'll understand the problem, and then we will add the condition as another predictor variable, and we have to do some modifications with that variable. We'll come to that in a minute. Right now, let's just look at these three variables. So we have predicted value of the price. Okay, b sub 0 is y-intercept. Now x sub 1 is square footage, x sub 2 is age, and these are the two slope coefficients, and we want to develop a regression results for that. So we're going to use Excel to generate the results. So let's head over to Excel. So this is the example. Here is the data, and first we will use only these two, and then we will include the condition. So as before, we have to first start by defining what the variables are. What is y? What is x sub 1? What is x sub 2? So y is selling price, x sub 1 is square footage, x sub 2 is age. All right. Now what is the model? So model is this. Okay, two slope coefficients, x sub 1 and x sub 2, and the mean of y is given by this. Okay, y is the mean of y plus an error. Estimate y hat will look like that. And by the way, y hat, you can get y hat from insert symbol, and then you have to look for it. It's there somewhere. You have to look for it. I think it's the MS sans serif or something like that. All right, so now we run the regression command. So data analysis, regression. Right. So selling price is y. No, x is the two columns, square footage and age. Okay, so make sure that you check label, and we want the regression output to start from here, and we don't want anything else. So click OK. so now we have the results. Let's go ahead and format the results. Okay, so let's okay, they don't have any decimal places there. Okay, let's make that into a percentage. All right, so all of this. Okay. All right. So let's go ahead and get the information assembled here. So y hat is 146,630.89 plus 43.82 times square footage minus 2898.69 times age except 2. And the r squared, which is the coefficient determination, is right there. So that means what? 67% of the variability in house prices is explained by our regression. So interpretation is